All right, so here we are in 2.1.3 of the lithosphere, still in key question 1. This is on plate tectonics. So we've talked about the structure of the Earth, the different layers. We've seen what's in the different layers of the Earth. Now we're going to get into actual plate tectonics. So plate tectonics, hopefully you should kind of be familiar with that from previous education. But plate tectonics are the moving of the plates around, making what we have today from what was previously once one supercontinent. And that's, of course, when we think about plate tectonics, we usually think about the land that is exposed from the ocean. But plate tectonics is the movement of not just that land, but all the crust, including the ocean floor, which is also part of the crust, right? This movement gives us the shape and distribution of our lands and oceans, and is a driving force behind a lot of the natural hazards that we're going to study soon, like earthquakes and volcanoes. But why does it move? And what on earth happens because of the movement? Well, all the crust, not just the continental, which is what we call the land-based crust, but the ocean floor as well, the oceanic crust, is broken into different tectonic plates that move in different ways. Here's a graphic of the major tectonic plates and the directions that they move. And as you can see, wherever these lines are that you see around here, right? You can see these lines through here. These are the tectonic plates. You can see they kind of take the shape of the actual land masses as well. So that's the African plate is not the continent of Africa. The African plate is what I just drew the red line around. And you can see the directions of the arrows. So as you can see, these two plates, the African plate is actually moving in this direction. I'm drawing the arrows. And the South American plate is moving this way, which means that this boundary right here, all right, is moving away from each other, right? Now, notice in the bottom, the key down here, we've got the terms subduction zone, divergent boundaries, and plate movement. These are going to be important to understand in the next section we're going to talk about, so we'll get to that later. But right now you might be thinking, okay, I just saw what Mr. Harshman did. I saw that he drew those arrows and that the African plate is moving away from the South American plate. Which one of those terms does that sound like it should be? So you can hypothesize what that's going to be, and then we'll get to that next section. All right. Where in America do we hear, if we look at that map, we hear most about earthquakes is in California. And I want you to look at that map real quick on the plate boundary, and if you see that, we've got this little plate right here, the Juan de Fuca plate, and it's really small, but we've also got the giant North American plate. All right, it goes all the way there. And we've got this huge Pacific plate, so two big plates, and we've got directional movement going on there. And so that directional movement actually lends itself to the reason why California has all those earthquakes. So if we take a zoomed in view of California, see there's that Juan de Fuca plate up in the upper left. The two boundaries and earthquakes go hand in hand. You can see that we've got the Pacific plate, the North American plate. Once you get zoomed in a little bit more, they actually move. If you look at this, we've got directional movement of the North American plate, which moves in different ways. And I know it showed the arrows a little bit differently, but you can kind of think of it as this arrow moving this way and the Pacific plate moving this way. So those giant plates, and this is just talking about the crust, so the crust of the Earth all the way down to the mantle, okay, is moving on top of the mantle in these directions. And what that does is that's going to cause friction to build up, all right, as these plates move past each other, against each other. And so this happens very, very slowly. But what will happen is that over time, that pressure will build up, and then at some point, it will break apart and it will snap. All right, and when it snaps, that can send the shock waves through California, which is why they have so many earthquakes, is because this is constantly happening. And so when there's a big stop, when there's like maybe a big rock up against another big rock underneath in the crust that's pushing against each other and it finally releases, that's when you get the bigger earthquakes in California. Now, other earthquakes are caused by other types of plate movement, and we'll talk about it later. But that's the earthquakes in California are caused by this type of boundary, which goes side by side, right? And look back at the map, the world map, and look at the mess of plates boundaries around Japan. Remember the big earthquake of 2011 that almost led to a nuclear disaster? It was caused the Fukushima meltdown, but we ended up being okay. Generally doesn't happen, and those things generally don't happen in places away from plate boundaries. So if we look back up here, this over here by Japan is the big mess of plate boundaries. There's all those different types of plate boundaries. Some are moving towards each other. Some are moving side by side. There's all kinds of plate boundaries around here, and they're all moving. So there are lots of earthquakes around here. In fact, it's called the Ring of Fire. We'll talk about that later because of all the different plate boundary movement that's there. So if we look at the plates over time, we're just going to look at the land masses here, and we can look at them over time in this animation. And you're going from 600 million years ago to today, and you can see that the land masses have changed over time into what we currently have today. And it's going to show it in a much slower motion, so you guys can watch that on your own in the blog. All right, so we tend to think usually that the land masses just move, what we see on top of the ocean. But you have to remember that was the entire crust, from the top of the highest mountain to the bottom of the deepest sea, and then down below that is the crust. So until you hit the mantle, even the stuff below the ocean is crust, all right? So it was the entire plates. So why do the plates move? It is not the land moving on top of the water. Please make sure that's out of your head. It's not the land just floating on top of the water, moving with the waves and stuff like that. It is land, solid land, moving on top of the mantle. Now, why does that happen? It happens because it's what's called uneven heat distribution in the mantle. Basically, there are cooler and warmer spots, and it's not evenly distributed. So when there is a temperature difference, temperature is the rate of kinetic energy, that the amount of kinetic energy, which is moving energy, that's what temperature measures. So when there is some places that are hot, that means the molecules and things are moving faster, and cold means they're moving slower. So the hot things will move into the cold areas. And what happens when there is uneven heat distribution in the mantle, so the mantle is this part below the crust right here, all right? The mantle is between my two red lines there, all right? When there is uneven heat distribution, it will move from hot to cold in a cyclical fashion. It'll get cooler as it moves up here, and then it'll get warmer as it gets compacted, and it'll move around and around. And when that happens, it almost acts like a treadmill, a conveyor belt, where the top, the crust, this area here, all right, will move according to that. So as you can see, if we have, let me change my color here. If we have this cycle moving around and around and around, the plate's going to move this way. And if we have this one moving around and around and around like this plate's going to move that way. And what's going to happen is you'll end up having a mid-oceanic ridge as those two plates move apart. And then you'll have this upwelling where new magma actually comes up through the earth and forms new land. So it's pretty cool. All right. That rolling movement of the mantle causes the crust to move. So that is a great graphic, and please go back and look at that. So as you can see, these things, those circular patterns are called convection cells, and those are pockets of heat transfer in the mantle. They move the two plates in the oceanic crust away from each other, and will move other plates like this one, all right, and this one. We'll be moving towards it, and the oceanic will be pushed underneath it. We'll talk about that in the next chapter. So that's the basic of plate tectonics. and we're going to get more into depth in that in the next section. All right, guys, don't forget to subscribe and smash that like button and get this page to go viral.